All right, so we're going to get started with our next session, what makes an open source project successful. Sam, I'm going to hand it over to you to do introductions.
Thank you, Ashley. And thank you, Clyde, for being here today to speak with us at Tau Days. So it's my pleasure to introduce Clyde Seepersad, the Senior Vice President and General Manager of Training and Certification at the Linux Foundation. And today he'll be discussing what makes an open source project successful. As I mentioned, Clyde is responsible for the training and certification arms of the Linux Foundation. The goal of the team is to provide high quality training and skills development to the open source community. Over the past decade, Clyde has held senior leadership positions in the education space, most recently as head of operations at 360training.com. And before that, as a senior executive of Houghton Mifflin Harcourt, a global leader in education. Prior to his involvement in education, Clyde was a principal at the Boston Consulting Group, a global strategic consultancy known for its cutting-edge thinking and value creation for clients. He started his career in the public sector, working with the Ministry of Finance in Trinidad and Tobago. He holds an MBA and Master's in Economics from Oxford University, where he was a Rhodes Scholar. And now it is my pleasure to turn it over to Clyde, get things started, and kick off the presentation. Thank you.
All right, thank you for that. Appreciate the opportunity to share some thoughts with this group. The Linux Foundation has been a premier organization in open source now for well over 20 years. And for the past 6 months or so, we've been working with Tau. So it's been really interesting to get involved in an educational community from the tech perspective. A lot of what we do on the broader side of technology acceleration and development cuts across multiple industries, but we hadn't done as much in the education space. So really excited to be part of this community and be doing it in an open source forum. I have a couple of slides that I will walk through, but I'm also going to keep an eye on the chat. So please feel free to put questions or comments in there, and we can stop and kind of work our way through those. I want to try to make sure we make this as conversational as possible instead of me just kind of broadcasting away for 30 or 40 minutes. So if you have like I said, questions or comments, please feel free to drop those in the chat so we can address them. What I thought I would do is start a little bit at the sort of highest level and just talk about open source software. So there's a what, why, where, who section here. And a good analogy, and it's a very close analogy, is if you think about the models of something like Encyclopedia Britannica, which if you're old enough like me, you still remember people actually going door to door trying to sell encyclopedias, and you contrast that with Wikipedia, which is very much a function of a group effort. And I think that is a great analogy to use to compare the sort of traditional model of software development where there was a single source of authority. And just like with an encyclopedia, the users would wait for new versions, right? So you have this canonical source. They would, whatever it is, every couple of years, release a new version. And that was published out to the world. Hugely valuable resource, created a lot of common knowledge base across, but pretty closed in terms of sources of input and how information gets put into the ecosystem. And you can contrast that with Wikipedia, where very democratic in terms of input. Pretty much anybody can sign up for an account, and you've got a tiered moderation system, right? So you can contribute a amendment to an article, and then that's going to eventually get reviewed and potentially tweaked or corrected. So they've got this built-in mechanism for group moderation and a tiered model for how how contributions get reviewed and then made available for the public. And that's very similar to open source software, right? The key differentiator is that you provide source code, so the actual code for the programming that anybody can inspect, modify, and enhance. Inspect is useful, right? Because you can see what is in the code and what it's actually trying to do and what it's not trying to do. Modify because you can make corrections, for instance, the things that you find, and enhance because you can then not just make corrections, you can actually propose new functionality directly in the code. And I think that idea that you're moving from the Britannica model where you're a user of the information, right? The system comes to you and you're consuming it. And that's where most companies and users, by the way, start in open source, right? Very few start off by trying to be contributors. Usually the framework is they've discovered a piece of technology. It really fits something that they're trying to do with their mission, and they incorporate it into their stack and they use it. And that probably feels very familiar to those of you in the education sector in terms of Tau, right? Really good piece of technology for the testing side of things, and you're able to incorporate that into your offering. And much like that to date has been much like the traditional model, where if you have changes, modifications, or enhancements, you go back to the source, as it were, to ask Tau to work on it. And what I'm going to suggest over the course of the next few minutes is a different model where more users get more involved. And we can talk about the benefits of you getting more involved and creating a shared collaborative experience in the software platform where you get these increasing returns to scale because you have multiple voices, sort of the Wikipedia model. So that's the what of open source software, right? You can actually get to the source code, and you have the opportunity, even if you start as a user, and it might be that it's perfectly well suited for your use case. I would urge you to think about the value that you bring both to your organization and to the collective group if you get into this mode of being able to inspect, modify, and enhance the software package. I want to maybe talk a little bit about why you would use open source software. And this is sort of the top 5 that I share with folks. The first is transparency, right? And so that's what the glasses are about. You can actually see the source code. You know what's in it. You can see what sort of subroutines are working. Every time there's a new release, you could go back and look at what the changes are. Being able to understand what is in your code creates a lot of confidence in terms of what you're able to do and how the system is doing what it's doing. Is there a backdoor? Is there not a backdoor? Does the encryption level look right? And so the idea of having transparency into the code is not something that you get with prepackaged software. It's a huge benefit of having an open source package where you can actually see down to the source code level and understand what is going on inside that program. And in the education instance, that's particularly important when we think about issues of privacy, for instance, right? To really have confidence that the software is handling sensitive student data in a way that is appropriate. The second is flexibility. So the idea that you could have the software be modified to meet your particular needs is really important. I think if you think of traditional off-the-shelf software, you might be in a position to make suggestions back to a product team, but you can't really directly make those changes. And as we get deeper into the world of open source, one of the things that starts to happen when you get to a mature ecosystem is you have the flexibility to take the base source code and you can write enhancements to it. And those enhancements you can then contribute back to the main projects we call upstreaming. You can upstream your changes back so that everybody can use them, but you do not have to. You can actually write an enhancement and keep it in what's called your own fork. So there's the main set of code that is coming through and it's available in the repository. It's entirely possible that you might want to write a proprietary, for your own internal use extension or enhancement and keep that piece of code in your own fork, in your own branch of the software, and then retrofit as the new versions of the core software come out, cross-test and maintain your own private piece of functionality. Now, in many cases, what you find is if it's really important functionality, it's less effort for you if you contributed that code back upstream, because then it becomes part of the overall software development lifecycle for quality assurance, for instance, as you go through the development process. So instead of you having to maintain it separately, it just becomes part of the core. And so that's one of the decisions that you can make in terms of the flexibility is if you start writing enhancements, do you contribute them back into the core or do you maintain them? And both models are perfectly valid, but it's a huge source of value that you don't get with proprietary systems. The third is cost. And so in pretty much every use case, the total cost of ownership on an open source program is going to be lower, in part because the development burden is shared across a number of organizations. And typically where you have dollars changing hands, obviously the general model is open source software. The code is not something that's charged for. And so really what you're paying for is professional fees. And so there's a structural difference in how the dollars get sort of flowing into the ecosystem. And in the case of open source, the total cost of ownership will be less over time. And especially with many of you being in the education field, and not profit-driven organizations, that's pretty attractive to have a source of software that is more affordable. The security is really important, and Linus Torvalds, who is the founder of the Linux operating system, has a quote that he uses, which is that given enough eyeballs, all bugs are shallow. And I think that speaks well to the security benefits of open source. It's not that there are never bugs in the code. It's not that there are never vulnerabilities, but because you've got the entire ecosystem, the developers and the users able to inspect the source code, the speed with which you can identify and remediate issues goes way up. And so you get this cumulative effect that the more people who are looking at the source code, the more rapidly you identify potential issues and the more rapidly you remediate those issues. And so the idea of security is not that there are never any bugs. I mean, there's plenty of public examples, including the recent Log4j vulnerability where open source software can be attacked. The big difference is that you've got source code visibility and you've got lots of eyeballs looking at problems and quite often finding issues before they turn into real world bugs. And then the last one is no vendor lock-in, right? And so one of the challenges historically with proprietary software is if you put a piece of it into your stack, over time you become very dependent on that one vendor. And with open source, you have you could be using a partner, but if you wanted to, you could pick up that code stack and move it over and have someone else work with you on implementing and maintaining the code. And so this idea that because you're in possession of the source code, you have strategic flexibility in terms of the vendor partners you choose to work with, that's really an important piece of it as well. So just to give you an overview in terms of some of the key benefits, which I suspect is for many of you is not news because you've chosen to use an open source program, but that's how we think about it at the foundation in terms of the benefits. So we talked about what, we talked about why, and who is you. I think when we started using it, as the Linux Foundation started getting into Tau, one of the questions we had from Mark and Teresa and the team was how much what we call velocity is there in the ecosystem, which means how many independent contributors are operating. And while there are a few, I think there's a lot more potential opportunity to get the user group involved so that you continue on this journey. Like I was saying before, almost everybody starts as a user, putting the software into the stack. The real key is, can we transition over time from the user mindset to the contributor mindset and all the benefits that accrue with that. And so, it very much is increasing returns to scale. The more people you have contributing, the more insights, the more creativity, the more functionality that you get. And one of the things that we'll talk about a little bit more is this idea of the strategic roadmap. And so how do you get from the ideas of the collective group, the collective user group, get those ideas for product enhancements and product roadmap into a forum where you can purposefully go after it with more bandwidth? Because I think one of the constraints of a model where there aren't as many contributors is you can have an imbalance between the number of good ideas about what you could potentially do with the product and the ability to actually develop that code. And so the more people that we can bring in to cross the threshold from user to contributor, the more bandwidth you create to be able to invest engineering time in really interesting features. And then a little bit on how many of you, I hope, are familiar with GitHub. There are other examples here, GitLab and others. But this idea that it's never been easier to inspect the source code. So GitHub is an online repository where these projects can have their source code living. And there is an edit control structure. So anybody with an account can review the source code and can do what's called a pull request, which means it's a piece of modification to the code. You can write up your modification, you upload it into the GitHub workflow, and then just like with Wikipedia with the subject reviewers, there's a hierarchy of folks who then look at that. And if the code is useful and it's not buggy and it's secure, they can then do what's called a merge. And so you get this up from a workflow perspective. The idea behind these Git-based systems is you really open the funnel up and make it very accessible for large numbers of people to potentially contribute ideas. And then you have this sort of layered structure of being able to go through, check the quality of the code, check the security of the code, and then incorporate, do what's called accept a pull request. And you can pull that code in and have that now be part of the new sort of base build. And this tooling has become much more mature, right? And so if you go back 10, 15 years, this idea of how you do version control on source code was very fragmented and very difficult and fraught with all sorts of issues about the security and the maintenance procedures. I think we've gotten to a place now where there's a really mature ecosystem to make it secure and easy to have multiple people contributing to a project. So that's a little bit on just the sort of overall structure and some of the rationale, the who, why, where, how of open source as just context for our discussion. I want to talk a little bit about the Linux Foundation, who we are and what we do. This catchphrase is something that we use to engage with audiences who might not be as familiar with us. But it speaks to the core of where the opportunities are in open source, which is decentralized innovation. So lots of people contributing ideas, and not just ideas, contributing code, but built on trust. So you've got these frameworks like Git-based frameworks like GitHub, GitLab, where you can really open it up to a broad community. People can contribute, but you've got a well-structured process to be able to modify and moderate that code and get it pulled up and put into the main production branch. At this point, we're managing 700 plus open source projects across everything from the core cloud computing stack to LF energy, to AI and machine learning, to the movies. I'll talk a little bit here about some of the different examples, but this concept that you should decentralize the innovation, right? Not just have one or two choke points within your ecosystem is something that's really, really powerful, and something that I would just encourage this group to really think about. And I think one of the beauties of the open source model is you don't have to have a earth-shattering idea for an enhancement. It could be really simple, right? It could be something in the user interface that you don't like, that maybe is confusing. It could be a label in a chart that's confusing. You can really start very small. You can pick a really specific thing, get into the source code, make that modification, contribute the patch, and let folks review it and see if it gets accepted. So you can really use what we call the crawl, walk, run model. You can start really small, one thing in the program that maybe as an enhancement, and go through the process and begin to get comfortable with the idea of being able to contribute the code. And part of what that requires is from a staffing and skills perspective, because that's often one of the challenges, right? Is you've got a user group that's using something for a key function in the organization, but they're not necessarily software engineers. And because you're able to start small, you don't necessarily have to go hire a team of software engineers to do this, right? You could, for instance, borrow a software engineer from another part of your organization and pull them in and say, hey, I have this one thing I'd like to improve. Can we work together on looking at that source code? And that way, by starting small, by maybe borrowing a resource as your jumping off point, you can dip your toe in the water and get comfortable with the model. And then gradually over time, you can get more, you can invest more heavily in those engineering resources, maybe as part of the core team. I'm looking at a question from Mike Carter on how do you handle different views to change things in a decentralized system. It's a good point. So there's two tiers at which divergent perspectives get managed. There is the first, which is the mainline sort of tactical piece, where different people might be submitting pull requests on a single piece of functionality. And those can get resolved through the normal sort of hierarchy of the software acceptance process. There's a sort of a more tactical level at which people might be contributing ideas. And back to the point I made earlier, because of the nature of how open source works and the fact that you're able to maintain your own code branch, it might be that the community decides to go with a solution that is different than the solution that you propose. And the beauty of open source means that you're not locked into that different decision. You can still take your own proposed code and have that overwrite the piece of functionality for your particular instance, in your particular branch, right? Your particular branch of the software. And so the access to the code means that you're able to make modifications, even if you're on the quote unquote losing end of a discussion. So that's the first piece, which is the very tactical sort of submissions-based piece. The second, and this is back to this sort of bigger picture of getting the user community to become the contributor community, is you've got typically, I shouldn't say typically, because actually it's universally. So for all the projects we manage, we have what's called a TAC, a technical advisory committee, and we have representatives on there, which we have elections from people in the user and engineering community, and the TAC decides on the roadmap, right? And so back to this point about decentralized innovation, you don't have the single company, in this case, that's driving the software exclusively making decisions about what gets put into the roadmap, right? You actually create this parallel body made up of the user and contributor community. In our model of the Linux Foundation, that's an elected group, and they make the decisions about the roadmap. So they take the feedback from all the folks in the user community, as well as the core engineering community that built the product, and they map out the priorities for development. And by having a fixed roadmap that says, okay, here are the things we want to focus on, you create more confidence in the direction of the project, but you also provide guidance to the engineers who want to contribute, right? Because maybe you're an engineer who started off and you got your feet wet making a couple of small contributions. As you get more and more involved, this idea of having a roadmap that you can refer to be able to say, okay, that's a priority. Let me go grab that piece of code, dig in there and see if there's a piece of that I can work on. So it sends a very strong signal to the development community about where they can put their efforts if they're looking for that next piece of project to bite off. Mike, hopefully that answers your question. Let's talk a little bit about the, what we call the not so secret ingredients for open source project success. And these are the 4 big areas where we invest in projects and where I encourage any project to really think about how you're setting it up. The first is this idea of this neutral home, right? And so I was just speaking to this in terms of the technical advisory committees, the TACs, as we call them. You've got to create an environment where people across the user spectrum feel like they're able to contribute their ideas and influence decisions about the roadmap. And that's where you get this, you really get this momentum of having a broad user base and lots of different ideas coming to the table. And this sense of confidence that the game isn't rigged, right? There aren't just 1 or 2 players that are driving the agenda forward, but you have this broad spectrum, representative spectrum from the user community. And so the rules of that TAC in our case, but the rules of your user group or your roadmap group, whatever label you want to put on it, making sure that that is neutral and that you're not granting disproportionate influence and power to particular groups, super important. The next one is care and feeding, right? Communities don't spring out of existence from nothingness, right? So you have to really think about, how do we get people in? How do we make it welcoming? And there's lots of tools that people can use. So for a lot of successful open source projects, for instance, there are meetups, which are typically city-based groups where folks who have a shared interest can get together once a month, at a pub and connect in real life and share experiences and share perspectives on the project. You have, newsletters and wiki pages and conferences. There's a whole number of tools within the toolkit for how you can take proactive steps to build the ecosystem, to grow that sense of community. The key insight there is, it does not have to just be always all about the code, right? There are steps you should be taking to think about the community and how you invest in the community and how you foster the community to get more and more people involved and have that sense of human connection and camaraderie, because that becomes an important piece of the puzzle in terms of getting to a really healthy ecosystem. So being mindful and intentional about thinking about this community of people and how you get them involved and how you keep them engaged is something that's really critical to the long-term health of a collaborative exercise like this. Support programs. So my day job at the Linux Foundation is training and certification. So we work with different projects to create high quality, affordable, in many cases free training programs to get to make it easier for new users to onboard, right? So this is the bridge between the previous bit, which is developing the community ecosystem of folks developing code, And the support programs is the flip side of that, which is how do you bring more users in? How do you get more awareness of the potential for what this project is able to deliver? And again, things like conferences can be helpful there. Training programs can be helpful there. Video tutorials, there's just a whole raft of things you can do to make it easier for folks to discover and adopt. I'm just looking at a question from John. Some of the folks who approach a testing situation have theft as a goal. Yeah, and so open source facilitates knowing how the defenses work. And the question is, how does open source help deal with those who have a goal of compromising the system? It's a great question. It's something that comes up across the spectrum when people think of this idea of having access to the code. I go back to the first point I made on the why slide, transparency, right? The fact that, there's always this cat and mouse game, right? Between the people who are looking for the vulnerabilities in the system and the people who are looking to defend the system. And so there are two main levels if you think about this idea of security, which I think is, John, at the heart of your question. The first is you want people in your community and this ecosystem we just talked about to be the what's called the white hats, right? So you guys are probably familiar with this term about the ones who are looking at the code with a view to thinking about, okay, how would somebody attack this code? Where are the potential vulnerabilities? And so just in as much as you always have folks looking with bad intent, this idea that you also have people with good intent looking at the code and trying to figure out where the vulnerabilities are. This idea of attack is one of the big pillars. And the second pillar is the idea that the source code itself is visible, right? And so one of the challenges with precompiled proprietary software is you don't know what's happening in the code, right? And there was instances of this, concerns, for instance, about TikTok. When TikTok, which is Chinese-based technology, very heavily directed at teenage users, there was a lot of concern about, this is supposedly a private company, but is the Chinese government somehow influencing what's happening behind the scenes with that data? Well, in that model, you just don't know, right? Because you don't have visibility down into the source code and the database to see what's happening. In open source software, you have that visibility, so you can see what's going on in the code, and you can see if people are putting things in that are a little bit nefarious. But you also, because you have this collective understanding of the source code, you can develop your system in such a way that you're aware of what the potential vulnerabilities are, in addition to maybe addressing those vulnerabilities. So you get this sort of holistic approach to security. And then, sorry, this last point on the slide is just about making data on the project available back to the user and the developer community, right? So things like progress against the roadmap. Can you see where that is? How far along? When is the next release? How many bugs have we fixed? What's the velocity of development? What's the tooling in terms of Git or whatever system that you're trying to use? And so that's the fourth piece, is just making it easier for people to understand the state of the project and to be able to then contribute more readily and be able to see where they are. If you've got a pull request on a particular item in the roadmap, that you can see from a development perspective where that's at. I'm just going to hop over to Jean-Philippe's question, that there's multiple types of content in TAO with, and so because you have this complexity, do you have sub-communities? And Jean-Philippe, the answer is yes. You get, just like you have with Wikipedia, right, where you have moderators at a sort of high-level domain, and then you have sub-moderators. The same thing's true in open source project. You have what's called maintainers, which are people responsible, ultimately responsible for the top level sort of sections of the software, and then sub maintainers, right? So in your example, you in a fully mature model, you might have somebody who is a sub-maintainer for all PCI compliance, and you might have a sub-maintainer who's responsible for import tools. And the PCI compliance one might roll up into a maintainer who's overall thinking about security, and the import tools might roll up into a maintainer who's thinking about, database structures, right? So that's one thing that you as a community would need to decide is what's the right spread of responsibilities in terms of maintainers and sub-maintainers. And in our model at the Linux Foundation, that decision about maintainers and sub-maintainers is something that the Technical Advisory Committee influences pretty heavily. So you get this, you get this democratization, right? Just because you're a maintainer today doesn't mean that you stay the maintainer on that forever. In fact, it's good to have some programmatic sort of rotation of the talent pools around so that you get fresh eyes on it, right? I think one of the secrets long-term for the success of an open source project is to constantly have some new perspectives rolling in terms of the roadmap and how it gets developed and what gets implemented. And so you really try to be purposeful about not having particular pieces of software become sort of proprietary. I know we're almost out of time here. I wanted to just maybe give a few examples to kind of bring this to life of some of the different groups that we've worked with. I'll start at the top left. Movie makers have historically been extremely sensitive to collaboration and not wanting to, because this idea is, I'm going to create the next blockbuster hit. And we spent about 5 years working with the different movie studios saying, look, you guys are all working on the same types of problems and you're all coming up with these independent solutions for things, for particularly as movies have shifted to being very heavily about computer animation and computer graphics. And so every studio had a program for how you render skin, and every student had a program about how you do smoke and water and liquids. And after a lot of encouragement and about 5 years worth of discussion, all the major movie studios got together and said, you know what, that's true. Like, nobody comes to our movie because our smoke is smokier or water is splashier. That's just table stakes. And by having different ecosystems and different toolings, we just make it really hard on ourselves to attract talent, because every time we hire an engineer, we have to go train them on our own proprietary stack. And so they really have gotten into this idea of a lot of the core technologies used for CGI are now part of a shared ecosystem where they're collaborating. And so instead of doing it 6 different times, you do it once. Automotive, another sector that's been, highly territorial and competitive. Over the past 10 or 12 years, we've gotten automotive grade Linux, which is now, by the way, in production. So Toyota has committed to that for its entire stack. Every Toyota Camry in the world since 2019 has been running automotive grade Linux as the core operating system. So not just the telematics of the car, but also the infotainment system, and being able to have a single code base, very modular. To your point, Jean-Philippe, about different people, some very, very different things, right? The braking system versus the radio system, right? Very different modules. But again, they're collaborating, and we're starting to see more and more of that coming into production as a standardized platform, an area that's not worth competing on. LF energy, and so this whole idea of renewable energies and the grid as a bidirectional system, right? So the old model was few power plants send the power out, gets contributed at the end. In a renewables model, you have rooftop solar and distributed wind. It becomes very much of a software play in terms of how do you manage that sort of grid. And I'm running out of time, so I won't go through all the examples here, but there's just sector after sector with this idea of LF Energy is a great example of where the initial feedback was, well, we don't have people who do software development, right? We're engineers in the classic sense of the word, but now they're realizing that every business is now a software business, and they're going to have to gradually build up some capabilities of how to think about a software control plane for a system that has become dramatically more complicated. I'm right on time, so I'm going to stop there. Appreciate everybody's attention. I'm going to keep an eye on the chat to see if anybody has any questions here before we wrap up.
And I think we just had one question, Clyde, in the Q&A as well, from Pierre Barley. When will Linux work on Mac using M1 Pro and M1 Max chips?
Put it into the tax queue of things for them to think about. There's been there's no sacred cows, right, in these roadmaps. So I don't know the answer as to when, but it's certainly something that you could tee up for discussion.
Great. Thank you so much for being with us today. We really appreciate you taking the time and sharing your insight with us and the rest of the panelists. It's been a very informative session. I think we all learned a lot.
All right. Thank you all.